By simply interpreting things the way I'm doing here, by thinking in terms of my time, the arrow of time, then everything will be solved. Therefore, should we talk about quantum gravity? What is quantum gravity? There is only gravity.
The ancient Greek philosopher Aristotle taught that heavier objects fall faster than lighter ones. An idea that, on the surface, makes sense. Even this surface, the Mars Yard, where they test the rovers at JPL. In fact, so reasonable, the view held for nearly 2,000 years, until challenged in the late 1500s by Italian mathematician Galileo Galilei. According to Aristotle, the bowling ball should fall over 15 times faster than the bouncy ball.
Well, they seem to fall at the same rate. This isn't that high, though. Maybe we should drop them from higher. So Ed is 20 feet in the air up there. Let's see if the balls fall at the same rate. Ready? 3, 2, 1, drop. Galileo was right. Aristotle, you lose.
Dropping feathers and hammers is misleading, thanks to air resistance.
Balls?
If you take the air out of the equation, everything falls at the same rate, even Aristotle. But what really interested Galileo was that an object dropped at one height didn't take twice as long to drop from twice as high. It accelerated. But how do you measure that? Everything is happening so fast.
Oh, yes!
Galileo came up with an ingenious solution. He built a ramp, an inclined plane, to slow the falling motion down so he could measure it.
So we're going to use this ramp to find the relationship between distance and time. For time, I'll use an arbitrary unit, a Galileo. 1 Galileo.
The length of the ramp that the ball rolls during 1 Galileo becomes 1 unit of distance.
So we've gone 1 unit of distance in 1 unit of time. Now let's try it for a 2 count. 1 Galileo, 2 Galileo.
In 2 units of time, the ball has rolled 4 units of distance.
Now let's see how far it goes in 3 Galileos. 1 Galileo, 2 Galileo, 3 Galileo.
In 3 units of time, the ball has gone 9 units of distance.
So there it is. There's a mathematical relationship here between time and distance.
Galileo's inspired use of a ramp had shown falling objects follow mathematical laws. The distance the ball traveled is directly proportional to the square of the time.
That mathematical relationship that Galileo observed is a mathematical expression of the physics of our universe.
Galileo's centuries-old mathematical observation about falling objects remains just as valid today.
It's the same mathematical expression that we can use to understand how objects might fall here on Earth, roll down a ramp. It's even a relationship that we used to land the Curiosity rover on the surface of Mars. That's the power of mathematics.
Because you see Galileo's and this one. Is there any difference? It is the same. The numbers are the same. The numbers are the same. Everything is the same. So the pattern is the same. So what is the problem? It is there. This is natural. That's why you can understand from here why things fall at the same rate. Anyway, there is a deeper explanation of all of this I'm talking about. Even these formulas here, you see, these are just a hint I'm giving to you. So if we want to go into the real formulas of this one, I will take you there. Therefore, let's not try alone, because it will take too much time to do it alone. It took me a lot of time to think about these things. I didn't come to the open like this just by enthusiasm. No. Even for me to really bring this one to life as you see it here, it took me months. So I had to really scrutinize, verify over and over before I will say anything before the world. So please, let's think in terms of a collective work. All the scientists will come together to now work on this mathematics. I am inviting you. Please understand what I'm saying. If you understand what I'm saying, you will get out of all this struggle about quantum gravity, because I tell you openly, quantum gravity is a wrong theory. It doesn't exist. There is only gravity. Gravity only. There are not two kinds of gravities. I think I'm very clear, and I'm saying it loudly because I'm certain of what I'm saying. I have a whole theory which will blow up your mind, because based on this you can explain the holographic principle. You can explain so many other things that Einstein was concerned about. So let's take it easy. I know that it is shocking news that you are receiving today, but take it easy. Do not take it personal, because mathematics are from nature. I didn't do anything to go and create this. It was revealed by nature. And now we are solving the problem. The problem has been there. We had infinites in our equations. Now we have to kick out all infinites. Infinite doesn't exist. There is no such thing like infinite in mathematics. If you had mathematics that gave you infinites before, they are wrong mathematics. Wrong. There's no infinite. So I would like to call the attention of everyone, and let's join me. Let's make our first move by coming together and discussing about all these things. I have a lot to reveal. Thank you very much.